HCF. Yes, started. So what is the full form of HCF? Highest common factor. And the other name of HCF is GCD, which says greatest common divisor. Okay. And LCM stands for lowest common multiple. Okay. So I believe you know what do we mean by highest or greatest. Also here, what do we mean by lowest? The other and common suggests that one particular number will not have any HCF. Like nobody will ask you what is the HCF of 36. There will always be two or more numbers for which we will be having HCF. The last term here is factor. So in last class, we have studied about factor. Like all the numbers which divides any particular number is here is its factor. We'll call all those number as factor of any other number when or if those number will divide the number n. So let's take an example. We have 36. So all the numbers which will divide 36 is, I'll be writing from greatest to lowest. 36, 18, 12, 9, 6, 4, 3, 2, 1. All these are factors of 36. So the highest factor is the number itself, and the smallest factor is 1. For all the number, it will be 1. So this true holds for all the numbers, and then we can have other factors in between them. Okay. So there will be always finite number of factors for any number. And in case of LCM, we have multiple, the third term, the multiple. So what do we mean by multiple? That all those numbers that we get by multiplying any integer to any particular number. Like, let's say we have 12. All the multiple of 12 will be 12 into 1, which is 12, 12 into 2, 24, 12 into 3, 36, 12 into 4, 48, like this. And there will be infinite number of multiples for any number. I'm just writing it because although it's not very important to know here, but I'm just letting you or getting you understand that how do we see factors and how do we see multiple. Now let's say there are two numbers, 40 and 60. So if someone is asking that what will be the highest common factor of these two numbers? So basically what we have to think is or see is I need to write all the factors of these two numbers like 40, 20, 10, 5, 4, 2, 1. And in case of 60, it's 60, 30, 20, 15, 12, 10, 6, 5, 4, 2, 3, 2, 1. So out of these factors, there will be some common factors. So by default, one will be common to both of them. One will be common to both of them. And there will be other common factors, like in this case, we have 2, we have 4, we have 5, we have 10, we have 20.
That's all.
Okay. So out of all these common factors, the highest will be, or highest is 20. So 20 is the GCD or HCF of these two numbers. Okay. So what did we actually see here or saw here is that for any set of numbers, there will be some common factors, and there may not be any other common factor than one. If no number is common, when no number is when no other factors are there in common,
அது
we will
மீட்டிங்
have
ஐடி
one. We'll have one. Like, let's say if I have 15 and 16, the factors are 15, 5, 3, 1. For 16, we have factors are 16, 8, 4, 2, 1. So what do we see here is there are no other common factor than 1. So we have just 1 as a factor, and that's why the HCF is 1 only. And all those pair of number or set of numbers which has 1 as HCF, we will call them co-prime. So you just need to remember this term. Co-prime are those numbers who don't have any other common factor than 1. Okay. So in co-prime or for a set of co-prime number, you don't have to have any prime. Like in this case, we have 15, we have 16. Both of these numbers are composite numbers, but together they are co-prime. So like many students gets confused that co-prime should have a prime number. It's not necessary. And of course, when there are two prime number, they of course will be co-prime in nature, like 5 and 7 will be co-prime to each other. Okay. So all those prime numbers together, they are co-prime, but to get a pair of co-prime, you don't have to have a prime number in the pair. Okay. So if nothing is, no other common factor is there, HCF will be 1. If few common factors are there, the largest common factor will be your GCD or HCF. Similarly, in the now, I think you all have got, you all have understood the concept of HCF. Okay. Now, let's go for LCM. So, we'll take the same set of number 40 and 60, and let's start writing the multiples of these two numbers. So, the first multiple will be 40, then 80, then 120, then 160, 200, 240, 300. Similarly, for 60, it will be 60, 120, 180, 240, 300, 360, like this. Okay. 420, 340. So, you know that multiples are infinite. So, there will be infinite number of multiples for both 40 and 60. And then start finding the common multiple. Like for 40 and 60, the first common multiple that we are getting is 120. Second common multiple that we are getting is 240. So, after getting the first common multiple, you can just visualize and observe that any multiple of 120 will be common multiple of 40 and 60. So all the common multiples of these two are 120, 240, 360, and like this. Here we will have 280, 320, 360. 360, 480, and like this. So again, we will have an infinite number of common multiples. Out of these, whichever is the smallest, whichever is the smallest, we will call this number as HCF of 40 and 60. Okay. So now everyone must have understood the concept of HCF and HCF, no, LCM. LCM of these two. So the smallest common multiple will be called LCM of 40 and 60. So did everyone get that? Still yes.
Yes, sir.
Okay,
Yes, sir.
very good. Now we will try to find out different way to calculate HCF and LCM. And we will have reasoning for both of all the method. So now the thing that I'm going to tell you the number of ways or different type of way, different ways to calculate HCF and LCM. First, I'll cover all the ways to calculate LCM, and then we'll try to find HCF. So let's say we have two number like 60 and 72. So there are these two numbers, and I want to calculate or find LCM of these two. So the first method that I've already explained, that what you will be doing is you'll write all the common multiple of 60 and 72, and you will get the smallest, or you'll get the first common multiple of 60 and 72. So rather than writing, if you don't want to write all the multiples of both number, you can just start with the largest number. See, and now this particular line is very important. When there are two numbers like 4 and 8. So here you can see that 8 is being divided by 4. Right? So the LCM of 4 and 8 will be 8 only. Or in other way, we can think of the smallest multiple of 72 is 72, and the smallest multiple of 60 is 60. Then the common multiple of these two numbers will not be less than 72. So what I'll do is I'll check with the biggest number or largest number from a group. So I'll start with 72. And since 72 is not divisible by 60, so I'll write the second multiple. Then I'll write third multiple. Then I'll write fourth multiple. Then I'll write fifth multiple. And I'll keep on checking whether it is getting divided by 60 or not, whether it is getting divided by 60 or not, whether it is getting divided by 60 or not, whether it is getting divided by 60 or not. The moment I got a number, a multiple of 72, which is also divisible by 60, this is my LCM. So this is one way to find LCM. Okay. So, okay, before finding LCM, let's find out all the way to find LCM. Because to find LCM, we will be getting help of this, like we'll be getting help of HCF also. So LCM is quite dependent on HCF also. So let's check for the HCF first. So let's take the same number, the same set of numbers, 60 and 72, or the method that I'll be telling you right now, it will be just parallel to this method of finding LCM only. So we have these two numbers, 60 and 72, and I know the highest factor of 60 is 60 and highest factor of 72 is 72. So in any case, the common factor will not be greater than 60. It will be less than or equal to 60 only, since 60 doesn't divide 72 then we will not be checking any factor of 72. We will not be checking that. We can just find the HCF by checking the factor of 60 only, because ultimately the highest common factor will be factor of both of them. So we will not check for 72, we'll just check for 60. So the first factor of 60 is 60 only, and 60 doesn't divide 72. The second highest factor of 60 is 30, and 30 doesn't divide 72. Then I have 20. 20 also don't divide or doesn't divide 72. Then I have 15. It also doesn't divide 72. Then I have 12. The moment I got 12, I found that 12 divides 72. Now we can confidently say that 12 would be HCF of 60 and 72. Okay. So now I'll be telling you a very interesting fact here. Before telling you that fact or that way of finding HCF, let me explain some one of the concept which is very basic and very interesting. Let's say a number. Let's say I'm taking a number 72. 72 or not. Let's not take 72. I don't want to get you confused. Let's say I have a number 56. And 56 divides 14. Oh, sorry, 56 gets divided by 14. So 14 divides 56. What do we mean by this? That 56 can be divided into integer sets of 14, like 14, 14, 14. In this way, I'll reach 56 in integer ways, like in 4 sets. Similarly, 84 also gets divided by 14. That means we can make set of 14 in 84 also, integer set of 14. So I know there are 6 sets of 14 in 84. That's why a number divides any number. So if we subtract 56 minus 84, I'll be getting 28. And by default, 28 will also get divided by 14. Why? Because 56 was the set of 14 and 84 was also set of 14. So 6 set of 14, or either here it was 4 set of 14. If I'll subtract, I'll be basically getting 2 sets of 14 only. So if a number divides in a reverse way, or in vice versa way, we can say if a number n divides x and a number n and the same number n divides y also. That means x and y both are divisible by n, and y is greater than x. This means that y minus x will also be divisible by n. That means if the remainder here is 0, remainder 0, that means the number is getting divided, completely divided. So I'll be getting remainder here is 0 also. Did everyone get this fact, or got this concept here? बताओ जल्दी, सबको समझ में आया? So now I'll use the same concept to find HCF. How I'll be finding HCF with this concept, you can just see here. Just a second. Just a second. So we were to calculate the HCF of 60 and 72. So let's say if there is a number which exists and which divides both other than 1. Let's say that if I had already told you that if there is no number, there is no other common factor than 1, that 1 will be the highest common factor. Let's say here a number x divides 60, and if it is HCF, if it is HCF, then it must divide 72 also, and then it's also should divide 12. Are you getting my point? The difference. No, I've already explained here. If a number n divides x, if a number n, the same number n divides y, then y minus x also be divisible by n. So similarly, if there is an HCF x which divides 60, there is an well, x will also divide 72 by the rule of HCF, and then by this division rule, the x will also divide 12. So now once I'll get the difference, I'll check or start checking from with this number only whether 12 divides 60 or not. So what we can see here is that 12 divides 60, and that means 12 will also divide 72 because it's a difference only. So here 12 will directly considered as HCF because this number. If 12, let me check let me give you another set of numbers. Let's say I have a number 220 and 260. So what I know here is, or by the same conceptualization, if x is an HCF, x will divide 220, x will also divide 260, and then x will also divide 40. So I'll start by checking 40, whether 40 divides 220 or not. It is not. Then I'll take the largest factor of 40 and after 40. So the largest factor of 40 after 40 is, second largest factor of 40 after 40 is 20. Then I'll check whether 20 divides 220 or not. It divides. Then it will also divide 260. So here 20 will be your HCF. Okay. So this is how we can find out HCF in such cases where numbers are not visible or the factors are not easily visible, but the difference is small. And we know that it will be less than that difference only. HCF will be less than that difference only, and it will be factor of that difference. So it becomes very easy to calculate HCF in such cases. Like, let me give you another example where you will find it is very easy or becomes very easy to calculate HCF. Let's say there is a number, what? There is a number 1080, and there is a number 1215. Okay. If these two numbers are there, and let's say you are being asked to calculate the HCF of these two numbers. Okay. HCF of these two numbers. So in any other way, if you write the factors of 1080 and 1215, it will be a very difficult job. So like I told you in the previous example, if any HCF exists X, it divides 1080. It also divides 1215. Then it will also divide the difference of these two numbers, which is, what is the difference? Tell me. 135. So this is the difference. So now I'll start checking or start checking from 135 whether 135 divides 1080 or not. Okay, 135 divides 1080 or not. So here what we can see that 135 actually divides 1080. Is it dividing? कोई बताओ मुझे. Is 138 divides 135 divides 1080?
Yes, sir. 135 into 8. is
Yes.
1080.
So this will be the HCF. And if let's say I'm writing here, let me write another number, not 135. Let's say 1250 is there, not 1250. Sorry. Let me check another number. We have a number 1242. So now the x will also divide the difference of these two. Previous was very easy. Then that's why I'm writing another number to make it little difficult. It will be 162. Okay. So I'll start checking from 162 whether 162 divides 1080 or not. है So it is being divided by 1080. Sorry, is 162 divides 1080? It will not. है Then I'll check the another number, next factor of 162, which is 81. Then I'll check next factor of 162, which is 54. Now I can see that probably 54 divides 1080. 54 divides 1080. So now 54 is the HCF of these two numbers. So in such cases where numbers are big but their difference are small, in those cases, finding HCF becomes easy. Okay. There are other ways to find HCFs. One is very traditional. You all know about this. In school, you must have done it. We start dividing dividing the bigger number from a smaller number like 1080. Let's start dividing 1242 by 1080. So this particular formula or trick that has been created, which you already know from your school, is basically the derivation of same thing. Okay, which I already explained you. So here you will divide. You will be finding that the difference is 162. Then I was telling you that 162 will check whether it's divide or not. So 1080. Then if it is not dividing, the remainders is the problem. So that's why with this, we keep on checking the remainder part. And with this, we keep on checking the factors part, which is basically we'll be finding as remainder. So if I'll do that, I'll be getting what? कितना होगा बताओ 162 into I think 5 or 6 9 16 into 6 कितना होता है 972. 972. What I'll get here is बताओ भाई 108. Then I'll divide 162 by 108. I'll not get HCF in this particular 54. And then 108, it will get divided. And this will be your HCF. So the method that you have learned in school is actually a very typical or very complex method. We never they never explained and they could never explain the reason why we are doing it. But this method will get you the HCF. But here, for exams, you don't have to use the same method. Other method you must have learned in your school in finding HCF is, like if you want to find the HCF of 1080 and 1242, you will be start writing the common multiple or find the common factor, sorry. So here I'll be having 540 and 621. Then I'll find 9, so 60 and 69. Then I will get again 3, 20 and 23. Now I'll not have anything common in between, common factor between 20 and 23. So I'll multiply all the factors which I have found to find HCF of these three numbers, these two numbers. So you will get 54. So these two methods you have already learned in school, and probably will not be using these two other than uh, some problem will be based on these two, then only we will use that. And it never happens actually. So our way of calculating HCF is more of understanding that there are few numbers, few factors which are common to uh, both the terms. Okay, just a second. So there are other ways to find HCF also, like 1080 is there, and 1242 was the another number. So in order to find the HCF, uh, what we'll do, I'll fetch or I will try to extract all the common factors like I did here. Here we were doing by writing the residual number. Here I'll try to fetch. So I know that both of these two numbers are divisible by 2 and 3. So I'll directly fetch 6. Whatever will be left, then I'll again, well, this is the same method that I have already taught you here. So with this, you will be getting 54. There is one more way to find HCF, which is very important. Like we'll write the prime factorization of both the number. So you know how to find factorization. 540, then 2, it will be 270, 2, 135, 3, 45, 3, 15, 3, then 5. If you write the prime factorization of this, it will be 6, 2, 1, 2, 0, 7, sorry. So the prime factorization of this number, we have already studied that in a studies class, how to do prime factorization. I'm just trying to find the common factor of these two numbers. So the two number can be written as 2 to the power 3 into 3 to the power 3 into 5. And here we have 2 into 3 to the power 3 into 23. Okay. So this was 1080, this was 1242. So how we will find the common factors from these two prime factorization? I'll check the common prime number and the smallest power of it. So the common prime number is 2 and the smallest power of 2 is 2 to the power 1. Then I have common prime number 3 and the smallest prime power. In this case, 3 is the power for both. 3 to the power 3 and 5 and 23 both are not common to any of these numbers. I think I made some mistake. नहीं ठीक है.
It's correct, sir.
Correct only.
हाँ हाँ ठीक
Correct,
है.
sir.
So correct. So here what I'll get is 54 as highest common factor. So this was another way to calculate HCF, which is very important. So all these method which I told you will have a complementary method or similar method to find HCF, sorry, LCM. So in case of LCM, let's find LCM through the help of prime factorization first. So we had this number 10801242, and the prime factorization was 2 to the, what was that? 2 to the power 3. 3 to the power 3 into 5. And here we have 2 to the power 1 into 3 to the power 3 into 23. See, I need to find, and now I have changed the question. Now I have to find LCM of these two numbers. So if you want to find an LCM of these two numbers, I need to write a number here at this box, which can get divided by 1080 as well as 1242, and it should be the smallest. Now find the restriction here. It should be the smallest. Okay. So what I'll do, I'll find the common prime. Okay, like 2 is the common prime, and I'll be writing the smallest power which is required. And here it will be the highest power out of these two. So 2 to the power 3 is basically the highest power of 2 in these two numbers, but is the smallest power which is required here for 2. Similarly, in the case of 3, the smallest power which is required is 2 to the power 3. See the change of sentence that I am making. Everywhere you will study or learn, they will be saying the highest power of 3. Of course, it will be the highest power of 3, but it will be the smallest required power of 3 also, which I need to write here. I will also have to cover this 5 because this number needs to get divided by 1080. And I will also have to multiply the number by 23 because this number also should get divided by 1 to 14. So this is how we get LCM with the help of prime factorization. So before going for other things for of LCM, let's go back to HCF again. Yeah? I'm shifting because I want to show you the clear picture or all the aspect of HCF and LCM. Of course, these are theory which you will be needing to solve even the complex problem also. So anybody who is just appearing or will be appearing for CUET only, they might not need to study in this detail. But of course, if you know, it will help. Okay. So because the concepts are important at every exam, okay, and every aptitude test. So we were finding SCF, we were finding SCF for 60 and 80 or many other pair of number. So any two number of world will have a HCF. You all know about this. And any two number of world or every two number of this world will have an HCF. Yeah. And we will denote this HCF as P. So here the number actually is 20 into 3 and 20 into 4. Here 20 was the HCF. 54 into 20. 54 into 23. Here we have 1200 into 3 and 1200 into 4. 1200 into 4. Okay. So what we are doing here is I'm writing all these pair of numbers as Px and Py. P is the common symbol for HCF. P is the symbol for HCF. So all these numbers we have represented here in Px and Py format. So now you can just visualize or realize it that any pair of number can be written in Px and Py format. So even these two numbers are co-prime, like 15 and 16, it can be written as 1 into 15 and 1 into 16. Okay. So what is the requirement of X and Y? What you can observe about this X and Y, that X and Y will are co-prime in nature. Co-prime in nature. What I mean is, you cannot find any other common factor between these two, because if there was any other common factor, it would have been increased, or we would have collected that into our HCF only. So the HCF it itself defines that other factors of the numbers are or will not have any common factor, which means X and Y will always be co-prime. So you can just see here 20 and 23 are co-prime, and 3 and 4 are co-prime. Here also you have 3 and 4. And now if you want to find LCM of these two number, or any two number which can be or which are being represented as Px and Py. So Px and Py, what do we mean here is that we need to find a number. We need to find a number which will be or which can be divided by Px and Py both, and it should be smallest in nature, because you need to find LCM, lowest common multiple. So what is the mandatory requirement for that number? That it must have P and it should have X also, because it needs to get divided by Px, and it should have Y also. So here what we are getting is what we are getting as LCM is Pxy. Pxy. This is the LCM. So this particular way of representing numbers is very important, and you'll be able to solve many questions through this concept. Yeah? Like there are two number n1 and n2, and P is the HCF. So these two number can be written as Px and Py. And the LCM will be Pxy. Now, if there are two number n1 and n2 which are being written as Px and Py, so let me calculate the multiplication of n1 and n2. What do we see here is n1 and n2 can be written as Px and Py, and then it can be redistributed, like we'll write P once and then Pxy. So here P denotes your HCF and XY denotes what? LCM. That I've already explained you. Now this was our LCM. So for two set of numbers, the multiplication of those number is multiplication of HCF into LCM. Now this is not true for three numbers or four numbers together. This is true for two numbers only. This is true for two numbers only. And this particular concept is going to help you a lot in uh, finding different questions or solving different questions. In next class, no, tomorrow's class, we'll be learning concepts of remainder, because many questions of LCM HCF will have remainder based question, and then we will solve few questions of or problems of HCF and LCM, and then we will move or extend our concepts of remainder further. Okay, so this is our agenda for tomorrow's class. I'm keeping this class little short because the things that I've taught you today is really important and complex, and it might have looked simple or easy, but it will actually will help you solve many questions. Okay, so all you need to do is you need to go through the recording again, and you can also check the previously done classes or conducted classes for